Hey everyone. Today we're going to look at the unit circle, which is extremely common at this point in mathematics. It's something that you can Google, and you're going to get kind of a bunch of images that show this like circular diagram that we'll learn about. It's going to be useful for converting radians to degrees, but also evaluating trig functions at various points. So that's kind of our end goal for the day. Your start here would be to, there are two special right triangles, and at this point we should know that they're 45, 45, 90 triangles. You could also call them pi over 4, pi over 4, pi over 2 triangles. And you've got this 30, 60, 90, which also, if we have in radians, pi over 3, pi over 6, pi over 2. And on both of these, I give you a hypotenuse of 1. And that's going to be kind of useful later on. But you should be able to simplify down to the answers that I have there. So square root 2 over 2 for both the sides or the legs in the 45, 45, 90. And then across from the 30 degrees, we should have a half. And opposite the 60 degrees, we should have square root 3 over 2. Okay, so check that. Ideally we kind of did this and then we're checking this, but it's fine if we did it the other way around. We just want to understand how we arrived at those values, okay? So then what we're going to do is step our way into the unit circle. So the first thing that I would say about the unit circle is it's a circle that's on the coordinate plane, so our xy axis. It's centered at 0, 0, and a very important feature of it is that it has a radius of 1. Okay, so you can see this little diagram here that I've drawn. So if that has a radius of 1, again, centered at 0, 0, this is going to be 1, comma 0, and you could come up with those other 3 cardinal points if you wanted to, but for our purposes, that's going to be kind of sufficient to just understand that basic premise there. And we're going to use our unit circle, like I said, to try helping us figure out certain trig values so that we don't need to plug them into our calculator. And this one, we can do based off our table from a few days ago, but we're going to find alternative methods and as well as extend our methods that we have in order to figure out something like sine of 45. So in order to do this, what we're going to do is we take a look at that circle that we have drawn, and I'm going to create an angle that's 45 degrees. So if I consider this always to basically be 0 degrees, then I'm going to go up by 45 degrees and create this line. So that will actually give me a triangle. If I drop that point down and connect it over here, I end up with this 45, 45, 90 triangle. Because this is a unit circle, I also know that my hypotenuse is 1. And based off our warm-up, which is why we did those triangles in particular, I can say that this side here is the square root of 2 over 2 square root of 2 over 2. And this side on the bottom of that triangle is also square root 2 over 2. One thing that we're going to be using this circle for in particular is to highlight the fact that the coordinates of that point where that ended up crossing is the square root of 2 over 2, comma, the square root of 2 over 2, right? So if I have that vertical distance here, that is going to represent, that's the same thing as my y coordinate, okay, because I went up square root of 2 over 2. Similarly with my x coordinate, I would get that from the bottom of that triangle. And if I had to figure out sine of 45, and I go way back to kind of the most basic understanding around SO, CA, TOA, I know that the sine of 45 has to be opposite divided by hypotenuse. The wonderful part about the unit circle is our hypotenuse is always 1. So this really just means that I just have to get my opposite value, so opposite that 45 degrees. And for the triangle that we have drawn, that is the same thing as our y coordinate. Okay, so sine of 45 degrees, I can say, all right, that's going to be the square root of 2 over 2. I get that from my triangle. If I'm ever calculating sine, know that it's just going to be our y-coordinate because it's always that opposite side from that angle that I have drawn. Okay, so we're going to take a look at kind of some other examples here. And I may even jump down to cosine of pi over 6 and then revisit tangent after that. So I'm just going to do a little bit of a switch up on this order here. So cosine of pi over 6, we should have, we can convert that to degrees if we need that visualization. We also know that, this is 0 radians off to the right, and that's pi radians off to the left. Pi is 180 degrees. If I take that and I divide it by 6, then I'm going to end up getting 30 degrees. So that's what I'm going to kind of attempt to draw here, is this 30-degree angle coming out and intersecting with my unit circle. So this angle in here is pi over 6, or 30 degrees. I know some people still need to kind of visualize that or have that understanding. And then this is going to come down. This is going to come over. So then here is, again, another special right triangle that fits onto this circle. It has a hypotenuse of 1. And then if I use, the warm-up problem that I had, or if I take a look at the previous table that we've created, we can come up with these other values. So along the bottom, this is going to be the square root of 3 over 2. And then this side here is 1 over 2. That gives us a coordinate here that we can use. So this is square root of 3 over 2, comma, 1/2 is my coordinate. Similarly, if I go back with cosine to the original understanding of it, this is adjacent divided by hypotenuse. But since we're on the unit circle, our hypotenuse is 1, so we don't really need to kind of do that. And we just end up with adjacent, or opposite of what we saw above. This can be given by the x-coordinate, right? So the adjacent side to that pi over 6 is square root of 3 over 2, which is just going to be our x-coordinate. So cosine of pi over 6 is square root of 3 over 2. If you plug in cosine of 30 degrees into your calculator, you'll get some number, and that number is equivalent to square root of 3 over 2. We prefer the radical just because it's going to be more accurate than that decimal that we end up with. Taking a look at another example here, which is going to highlight some slight differences. We're doing the tangent of 3 pi over 4. So tangent of 3 pi over 4. So this ends up being 135 degrees. Let's give a little erase here. So if I'm starting with this being 0 degrees, and I go 135 degrees around, and I draw this, okay, I'm still always taking from that point and dropping down to my x-axis, and this becomes my triangle. And if we can understand, that triangle that we ended up forming is really just a 45, 45, 90 triangle right here. We still have a hypotenuse of 1 because it's the unit circle, and both of these legs, based off our warm-up, are square root 2 over 2. Okay, so even though I'm finding the tangent of 135 degrees, it's still going to be governed by this 45, 45, 90 triangle here. Going back to kind of my basic understanding of this, this is opposite over adjacent. And actually, if I come up with this coordinate now, be careful here, is actually negative square root 2 over 2, comma, root 2 over 2. So it's negative because, if I'm on the coordinate plane and I'm moving to the left side of the y-axis, that's going to give me a negative coordinate. I might not go so far, I'll put it here, but sometimes it doesn't always make sense because distance is a positive value. But that's where that negative is coming from, is that I am moving to the left here. So if I need to do opposite over adjacent here, so opposite is first this value. Okay, so opposite is going to be my y coordinate divided by my x coordinate. So this is y over x. So this is going to give me square root of 2 over 2, and then I'm going to use a larger fraction here, negative square root 2 over 2. Anything divided by itself is 1, and a positive divided by a negative is a negative. So I'm going to get negative 1 here. And that is kind of that same usage. So a little bit trickier. We're going to spend a lot of time in class kind of going over some of these same things and some of the minutia behind it. But we learned basically that cosine, if I'm finding the cosine and I have the unit circle, then I can just grab the x coordinate. Okay? If I'm grabbing the sine of something, then I can just grab the y coordinate from the unit circle. And if I'm doing tangent, I probably still have some work to do, but I can also just do y divided by x. So my y coordinate divided by my x coordinate. And let's just kind of summarize that here. So sine of some angle, which was the opposite, I can just use my y coordinate, cosine is my x coordinate, and then tangent, since it's opposite over adjacent, is y over x. So I can, underneath here, we've actually got a completed unit circle, which I'm going to erase a little bit of, but you can, I've completed it and uploaded the finished kind of notes online. But I'm going to show you kind of how we can derive this or how we can understand this. And I'll just erase kind of some of these and keep others, just so that you still have some to kind of refer back to or take a look at. So the important part about the unit circle and kind of the basic pieces to it is on the inside we have the angle measures. First, they're given in radians. So I could consider this angle along the x-axis either 0 radians or 2 pi if I make a full rotation. And then they're also given in degrees. So again, only this point is going to have 2 different variations, like 0 or 360. As I go up, all I'm doing is really going by the 30, 60, 90 triangles or a 45, 45, 90. So this would be 30 degrees, 45 degrees, 60 degrees. So we see that we're making those 3 different triangles. So this is going to be pi over 6. Then I'm going to end up with pi over 4 and pi over 3 for those conversions. And you can check kind of the completed one for that as well. Then along the outside, I have, these are going to be basically the sides of my special right triangles, or the coordinates of those once they kind of intersect. So we can get those directly from our warm-up. We've drawn this triangle before, but if I take this, drop it down, and I consider this 30, 60, 90 triangle, then I know that this side down here is square root of 3 over 2. This is a half, which means that the coordinate of that point here is square root of 3 over 2, and then a half. Oop. Let me kind of correct this one. It looks a little sloppy. So square root of 3 over 2. All right. For our 45, 45, 90, if I keep drawing the triangles in there, it's going to end up getting a little bit messy. But this is square root of 2 over 2, square root of 2 over 2. And then we notice that for this 60, it's actually the same thing as the 30. It's just flipped. So it's going to be a half and then square root of 3 over 2. If you can get one quadrant done, normally you can jump to the other values. So notice here I have a half and square root of 3 over 2. Well, that's going to help us figure out these points over here. The height didn't change, so the height of this point and this point are both going to be square root of 3 over 2, but then my x-coordinate is going to go from positive to negative over here. So all those points are really just reflections, and that works, that same logic applies down here if I'm trying to figure out these coordinates is that my x doesn't change at all, so this is going to be a half from the point directly above it, but the y coordinate is going to change to negative square root of 3 over 2. So part of this is completing this unit circle, and I would say that's the most important thing that we are able to do. There will be kind of a completed diagram for it as well, so at the very least we need to have that copied down for our kind of upcoming lesson Thursday. But it's also useful if I have to do something like this. So I know that cosine of theta is my x-coordinate, sine of theta is my y, tangent of theta is y divided by x. This is kind of our tricky one. But otherwise, if I have to do something like this, and I have the unit circle completed again, so cosine of 60 degrees. Well, cosine is my x-coordinate. And if I'm doing 60 degrees, then I can look on this diagram and say, okay, where is 60 degrees? 60 degrees, that's not exactly what I wanted. 60 degrees is right here. Look at me go. So then I can say, okay, cosine, I just said, was my x-coordinate. So that's going to give me 1/2 because the x-coordinate at that point is 1/2. So then I can just plug in 1/2. And all these other ones should fall on that unit circle as well. And it's mostly just going to be a matter of finding either the x-coordinate or the y-coordinate if you're doing cosine or sine, or if you're doing tangent to try to do y divided by x. So in order of what I kind of want us to do, step 1, first and foremost, is to complete that unit circle. And then at the very least, the expression kind of goes, give these a college try, but see how they go, because this is going to be what we're practicing when we come back in. All right, thanks everyone.